Alright, you're about to witness something truly insane. The AV-8B Harrier II, one of the most iconic vertical takeoff and landing jets in the world, is about to pull off its signature move on the deck of a moving aircraft carrier. This isn't CGI. This is real. Welcome to the raw, deafening, high-stakes world of naval aviation. Right now, we're watching the Harrier slowly taxi into position. Every move on this flight deck is choreographed to the second, coordinated hand signals, flashing lights, roaring engines, and the ever-present noise of jets piercing the sea air. This aircraft doesn't need a catapult. It doesn't need a long runway. What you're going to see is a jet literally jump into the sky, almost straight up, using nothing but raw thrust-vectored nozzles and serious pilot skill. It's part fighter jet, part rocket, and 100% mechanical beast. The Harrier pauses for a moment. You can feel the tension on the deck. Flight crew huddle near the sides. The jet's Rolls-Royce Pegasus engine begins to scream louder, building pressure. Hitting the deck below with its vertical thrust vectoring system, the nozzles begin to pivot downward. This is the moment. Boom! With a roar that shakes the deck, the Harrier lifts off. Not like a regular jet, but like something out of science fiction. It hovers a few feet above the surface, then angles slightly forward, balancing the raw vertical power with forward momentum. And just like that, it's gone, launching off the deck with a blast of exhaust and a trail of heat distortion trailing behind. No runway needed, just pure engineering magic. Let's break this down. The AV-8B Harrier II is a second-generation V/STOL aircraft designed for both attack and close air support missions. It was developed primarily for the U.S. Marine Corps in collaboration with McDonnell Douglas, now Boeing, and British Aerospace. Its unique ability to operate from forward bases, makeshift airfields, and carriers without catapults gives it unmatched tactical flexibility. But what really sets a Harrier apart is its thrust vectoring system. 4 rotating nozzles, 2 on each side, can redirect the jet's engine exhaust downwards, allowing it to hover, take off vertically, or land in tight spots. Combine that with reaction control valves at the wingtips, nose, and tail, and you've got full control even while hovering. Now, let's talk about what the pilot is dealing with in the cockpit. Managing a Harrier jump is no joke. It's not just throttle and stick. Pilots are controlling nozzle angle, balance, altitude, and drift. Even a slight mistake can lead to a catastrophic loss of control. The vertical takeoff burns a massive amount of fuel. That's why the Harrier typically performs a short takeoff when possible, using the ship's forward momentum and deck length to reduce the vertical lift required. But today's demonstration, full vertical launch, a true showcase of power. We're getting a close-up now from the carrier deck camera. You can see the scorched steel with the jet's exhaust hammer the surface. Crew rush in immediately after departure to inspect the area, checking for damage and preparing the deck for the next sortie. Everything on a carrier runs like a machine with precision, speed, and zero room for error. Meanwhile, in the sky, the Harrier banks hard to the left. From the deck cam, you can hear the faint echo of its jet roar. Within seconds, it's just a dot in the sky, on patrol or ready for the next training run. Let's take a moment to appreciate just how rare this capability is. Most jets require long runways or complex carrier launch systems. The Harrier? It was designed from day one to operate where others can't. That means forward operating bases, remote islands, or even damaged runways. In real combat scenarios, this is a game changer. Now we're switching to the pilot's helmet cam. This view is breathtaking. You see the deck shrinking below, the nose of the Harrier lifting toward the sky, the altimeter climbing. The engine is at full thrust. There's heat distortion around the cockpit glass, and the ship's wake is visible far below in the ocean. The pilot calls out altitude and bearing. His voice is calm, routine, even, but make no mistake, this is precision flying. One wrong move in hover mode, and the aircraft could roll, stall, or drop. Back in the carrier control room, you can see officers monitoring the radar and flight deck status. Every aircraft movement is tracked. These operations are coordinated down to the second. Here comes the next part, landing. And this is where the Harrier's magic really shows. While other jets perform high-speed arrested landings, the Harrier can stop midair and gently drop onto the deck. You can see it now on approach. The nose dips slightly. The nozzles angle downward again. The landing gear extends. From a side camera, we can see the jet hovering about 30 feet above the deck. The engine noise is deafening. Heat waves ripple through the air. The pilot adjusts position, using small thrust corrections, like balancing on a pencil tip. And then, boom, it touches down. Softly, gracefully, as if it weighed nothing at all. The jet settles, engine winding down, and the deck crew rushes in to secure it. Mission complete. This entire process, from takeoff to landing, is a masterclass in engineering and human skill. Few aircraft in the world can do what the Harrier just did, and even fewer pilots can pull it off. Let's talk history for a moment. The original Harrier concept began in the UK during the Cold War, with the British Hawker Siddeley Harrier in the 1960s. The AV-8B is the evolved American version, upgraded with a new wing design, composite fuselage, better avionics, and increased payload capacity. It served in countless conflicts: the Falklands, the Gulf War, Iraq, and Afghanistan. Its ability to provide close air support in tight spots, where traditional airfields were inaccessible, made it a favorite of the Marine Corps. Now, as we pan across the deck, we can see several Harriers lined up, ready for deployment. Each one has its own mission, loadout, and pilot. Some armed for air-to-ground, others configured for reconnaissance or patrol. The deck crew in their colored jerseys, yellow for aircraft directors, purple for fuel, green for catapult and arresting gear, work like a choreographed dance.